Hi, Dr. Birch here again. So now we're going to finish up part B of this lab, where we're going to measure out 10 mils of water using a volumetric pipette. So this is a volumetric pipette. So at the top, it has what volume it delivers. So these volumetric pipettes come in different sizes. They're calibrated to deliver a specific amount of a substance. In this case, this one measures 10 mils, right? So you can only really measure out 10 milliliters using this volumetric pipette. So the way it works is we'll use a pipette bulb here. We'll put this on the top, we'll squeeze it, it'll then pull up our water or whatever liquid we're measuring out into the pipette. And then you'll notice there's a line right here. That's the marker that tells you where 10 milliliters is. So we'll measure it, we'll pull up our water so that our meniscus is right at this line. And then that tells us that that's our 10 milliliters. And then that's how we can then let the water run out into our container, and it'll deliver 10 mils into whatever container we're trying to deliver it to. So on the last two, with our beaker and our graduated cylinder, we were able to measure our beaker or a grad cylinder on the balance directly. However, we can't put this pipette onto the balance to weigh it, right? Because it's open on both ends, right? It's also kind of long and awkward. It would be very hard to put it on there. So the way we're gonna do this is we're gonna use our beaker again. So we're gonna measure our beaker's mass, then we'll use our volumetric pipette, measure out 10 mils. We'll put that 10 mils into this beaker, reweigh it again, and then we can get our mass of water that we delivered. So we'll start out by weighing the mass of our empty 50 milliliter beaker. So we'll record this mass as the empty beaker for this part of our experiment. So now we have the mass of our empty beaker. So now we're gonna go and measure up 10 milliliters using our volumetric pipette. So using our bulb, we're gonna squeeze the top up here, which releases a little valve inside, so then that allows us to then squeeze the bulb closed. All right, so basically, when we then open this, it creates a little vacuum and will suction up the water into our pipette. So then we slide the tip of this pipette bulb onto the top of our pipette. Next, we'll then put this into our beaker of water, and then we'll squeeze this part of our valve, which then allows the pipette bulb to expand, creating a suction, pulling the water up into our volumetric pipette. So when we're using this, we're going to pull the level of water up above where we want it to be. The reason we do that is because we then have to take this pipette bulb off, right? So what I'm gonna do is pull this off and then put my finger on top, so that way it holds it where the line is, right? So now, if I slowly pull my finger off, you'll notice the water level slowly goes down, and then I'll let it run down till the meniscus is right at that 10 milliliter marker. So you notice right there, the meniscus is at our line. So now I'm gonna take the pipette, put it into our beaker, take my finger off, and let it run down. All right, so you'll notice that the water is slowly emptying out of our pipette, and it's gonna deliver 10 milliliters into our beaker. Sometimes there'll be a little drop of water at the end of the pipette. You'll just kind of want to touch that to the side, and that will get the drop off. And then normally there's a small amount that remains in the pipette. That's normal. They're calibrated to kind of have that extra little bit that just stays inside of our pipette. So now we've gotten our 10 milliliters into our beaker. So now we're going to weigh this again. So you'll record this mass as then the mass of the beaker with water that was delivered from our volumetric pipette. So just like before, you could then subtract those two masses. That'll tell you the total mass of water that we delivered into our beaker using our volumetric pipette, and you can use the density to then calculate the volume that we delivered with our volumetric pipette.